Hello again, this is Tim Baldridge, and today I want to talk about concatenative languages. Common languages in this category are languages like Forth, and I think there's one called on the JVM called Factor. Um, but at any rate, they're a stack-based language. And so let's take a look at what a program would look like in this format. So we're going to create a string here, and we're going to say take 1 and 2 and add them, and 1 and add that to the result of the first computation. So as you see, unlike Clojure, which this same program would look like this, instead of the function being on the left, it actually comes on the right. Now we still execute from left to right, but everything looks like a stack. So we take 1 and push it onto a stack, and 2 and push it onto a stack. And then this plus says add those two numbers. So it takes 2 items off the stack and adds it. And then we push 1 onto the stack and add that to the result. So once plus actually is done computing its result, it pushes the result back onto the stack. Okay. So if we have this program today, we can parse the program simply by doing read string and a little hack I do for this sort of thing, like this. Right? Apparently I'm not in the right namespace, so let's try that. There we go. So we have program, and we read our program, and we have a parsed program. So if we take a look at that, we see that we have a vector of 1, 2, plus 1, plus. Okay, so we're basically hijacking the Clojure parser to parse our program string. We could also have just done this as a literal sequence, but whatever. It's fine to do it this way. So once we have that, we are going to define a state of our interpreter. So def record, and we're going to have data state, or the data stack, the program stack, and the environment. And let's get rid of these keywords here because those aren't keywords yet. And we'll do program state. And let's just name it state for now. It'll be easier to see what's going on, right? Okay, so now we can create a function, new state for program, right? And what we can do is create a record where our data state is a nil, our program state is program, and our environment is an empty hash map. Good. Now we can do new state parsed program, and there we go. So our state is nil, we have our program to execute, and our environment. So most languages like this, concatenative languages, and I'm going to trip up on that pronunciation several times in this tutorial series, so I apologize up front for that. But in concatenative languages, we often have 2 stacks. We have a data stack and a program stack. And the program stack is the remaining computations that we have to execute. And the data stack is kind of a scratch space, right? So we can put things on and on off and on that stack. So now let's go up here and let's create a protocol and call this IEval. And this is anything that can be evaluated. So each one of the things in our stack here can be evaluated, right? And no, cursive, I really don't want you to import that, thank you. So we're going to go and call this IEval, and we're going to have a function eval, and this and state, right? So we're going to pass each thing the state. Now we can do extend protocol for Java, why can I think of it, long? There we go. So Java lang long, and we actually want to extend the protocol, so IEval, there we go. So for each one of those, eval, this and state, what we're simply going to do is return a new state. Soch into state. The new data stack is the old data stack. So let's destructure that up here. Keys ds of as state, right? we are going to simply cons onto the old data state this, right? So what you see we've done here is we've taken the old state, we get the data stack, and then we add on to the head of the data stack this, which is basically a 1. So evaluating a 1, it evaluates to itself, and it puts itself on the stack, right? Okay, so that works. Now what we need, though, is a evaluation loop, an interpret loop, right? So let's build that up. Let's do loop, interpret. So we're going to interpret state, and we are going to, we could probably do this as a no, we're not going to do this as a reduce, actually. We're going to say loop. So for each thing in loop, what we're going to do is say, if we still have a program state, and we're going to state. If we still have a program state, then we're going to get let's see here. So we're going to get the item and the program state, item and the rest of the state from the current program state. So what this is doing is this is going off and getting the head, right? It's getting the head and the tail off of our program state, which is this. So the first time we execute this, we will get 1, right? And then after we get, so that would be 1, and this would be the rest of the program. So now we need to update the program state to kind of go to the next item, if you will, right? So we're going to eval item and assoc into state ps, right? So that's our new state. And we can just recur with that. So this will continue on until we have no more program state. And then we are going to just return state. Okay, so let's give this a try. So now if we say interpret, we should get an error. It says no implementation of eval found for symbol. Okay, so to do this a little bit better, let's each time we recur here, print the state. Okay, so we see what's happening here, right? Let's expand this a little bit. So the first time our data state is null, and we have this program state. So we're going to pop 1 off of that and eval that. And what does that give us? Well, 1 evals to itself and pushes that on the data state. So we push that onto the data state. Now our stack here is growing the opposite way, and maybe we could update that a little bit. But we'll just have to see that we're reading and writing to this part here, to the left-hand side of the stack, right? These are cons cells, so they grow leftwards. So we eval 1, and 1 is on the stack. We eval 2, 2 is on the stack, and 1 is on the stack. And now here's our program. So what we're complaining about here is that there's no implementation of eval found for symbol. So we're going to hack in something here. Clojure.lang.symbol. So we're going to get keys, ds, state. So we're going to get the data state. So now what we're going to do in this case is we're going to assume that the only symbol we support at this point is the plus, right? So we can even assert equals this plus, right? We can even, to do implement more. There we go. So what we would do in a real case is look this up in the environment, but for now we're not going to do that. We're just going to run with this right here. So now we assoc into state. First thing we need to do is we need to get 2 items from the state, right? So because we're pulling these off the left-hand side in inverse order, we can do B and A and data state. So that's our data state from DS. So we're going to create a new data state after we pull B and A. And we're doing not A and B, but B and A because we're pulling the second item off first. They're kind of flipped in order here. So we're pulling off 2 and then 1, right? So now what we can do is update the data state with the sum of A and B. And we need to cons that onto our data state. right? Boom. So now let's interpret this. So what do we get? We get 1 and 2. Now we execute add. Add puts 3 on the stack. It pulls off 1 and 2 and adds 3. Then we evaluate 1. Now we have 1 and 3, and we add, and we get 4, right? So here is one of the things that I just love about concatenative languages. Look how simple this is, right? Like we can talk about the simplicity of different languages, right? A Lisp is a pretty simple language. But look at this. I mean, this is only, what, 20 lines of code? And we have the basics for a full language here. We would just need to add more functions that do more things, right? Because the state is passed in, we can do lots of things with the state. And we'll talk about that in the next lesson. We can manipulate the program stack as well as the data stack. As well as we have the environment here. So we could really just look up something in the environment if we wanted. That's the tutorial for today. In the next tutorial, we'll hook this into some Clojure functions and get a little more power out of this thing. But that's the tutorial for today. Thank you for watching.